What compound is likely to form when magnesium reacts with nitrogen? So let's get our symbols for magnesium and nitrogen. Magnesium is capital Mg, nitrogen is just capital N. Mg and N. Again, notice I'm always putting the metal on the left side and the non-metal on the right side. That is just good practice. Now that we've got the symbols, we need our charges. Magnesium has a 2 positive charge because it's in group 2. Nitrogen has a 3 minus charge because it's in group 15. 2 positive, 3 minus. So just like all of our other examples, when these two are drawn to each other, they're going to be drawn to each other rather, because they have opposite charges. But what we're going to see happen here is something interesting. The 2 positive charges are going to try and cancel the 3 minus over here. 2 positive, however, is only enough to cancel out 2 negative. So it does do that, but it leaves a 1 minus charge on our nitrogen. All right. Since this nitrogen still has a charge, the magnesium is stuck to the nitrogen, but it leaves a 1 minus charge on the nitrogen. This 1 minus charge is still going to draw in any other positive charges that are around. And since a sample of magnesium is going to have billions of magnesium atoms, there's going to be another 2 positive magnesium atom in the area. So this 1 minus charge on the nitrogen is going to draw in another magnesium with a 2 positive charge. When these get close enough together, this 1 minus charge is going to cancel out one of the positive charges over here, and that leaves a 1 positive charge on this magnesium. This magnesium is in fact stuck to the nitrogen, so this nitrogen now has 2 magnesium stuck to it. And since this magnesium has a positive charge, it's going to draw in any negative charge in the areas. And guess what? There's another nitrogen with a 3 minus charge in the area. This positive charge attracts it over. This 3 minus on the nitrogen is going to cancel out with the 1 positive. When that happens, a 1 positive is enough to cancel out one of the negative charges on this nitrogen. 3 minus 1, what is going on here? 3 minus 1 is 2, so we still have 2 negative charges on this nitrogen. However, our compound here is getting pretty big. We've got currently 2 magnesiums stuck to 2 nitrogens. And even though we have 2 magnesium stuck to 2 nitrogens, this nitrogen still has a 2 negative charge. And it's going to draw in any other positive charge in the area. And guess what? There's another magnesium with 2 positive charges in the area. And hopefully you can see what's going to happen here. This positive magnesium is going to be drawn to the 2 minus on the nitrogen. And we have a 2 minus and a 2 positive. These two can finally perfectly cancel out, leaving our compound neutral overall. It just took quite a bit of work to get there. We had to go back and forth for a while, canceling, recanceling, until finally we get a neutral compound. When we go to write our formula, again, always write the metal first. Our metal is magnesium. Then write your nonmetal, which is nitrogen. After you've got your 2 elements, or however many you have, write your subscripts, which again tell you how many of each you have. So how many magnesiums do we have? 1, 2, 3. So I'm going to put a 3 as a subscript. How many nitrogens do I have? 1, 2. So my compound is magnesium 3, nitrogen 2.